You guys can call me.
Alright, on this sheet that I just gave you, there are some problems that are just like what we did yesterday, okay, reflecting across vertical and horizontal lines. Do you guys feel like you need more practice on that or not?
Yeah.
I'm still here. Maybe you get it in the horizontal.
That's not horizontal. This is horizontal.
One like this, wasn't like.
Okay, well, that's the new thing that we're gonna do today. Okay. So what?
Perpendicular.
Perpendicular.
Yeah,
Oh, yeah, that's what we're gonna do today. But what I'm asking first is if we need any more practice on what we did yesterday, reflecting across horizontal and vertical lines. Right. Yeah. Right. Yeah. Yeah, you just count the same distance, or count the distance from your point to the line of reflection, and go that same distance on the other side. Okay, so do we, general consensus, feel like we need a little more practice or not? Well, if you weren't here, okay, then you can try a couple of these. But I think for the most part, okay, we feel comfortable with what we did yesterday, so I'm not going to make you do more pointless practice. Alright, so we do have one new idea with reflections today, though, reflecting across lines that aren't completely vertical or completely horizontal, like y equals x or y equals negative x. So if we look at number 9 on the paper, right, on the back, number 9 says take this triangle and reflect it across the line y equals x. So first of all, what does the line y equals x even look like? No idea. So if we think about y equals mx plus b, right, I want to graph a line. So the two things I'm looking at are the y-intercept and slope. So what's the y-intercept of y equals x?
0.
0. Right? Plus, there's nothing being added. So the b value would be 0. That means my y-intercept is 0. Then what's my slope? 1. Right? If we have a 1 over 1, we end up with this line right here. This is my line y equals x. So now it says plot these coordinates. So -5, 5, -2, that's x, -3, 4 is y, and then z is at -1, 1. So I want to take this triangle and reflect it across the line y equals x. Okay, so if we kind of visualize reflecting, it should end up kind of like down here somewhere. Right? If I take this, flip it across this line, we're going to end up down here somewhere. The way that we're going to do this is really similar to what we did yesterday. Okay, we're still going to count the distance from each point to the line of reflection. Okay, so if we start with x, it does not matter if I go right or down. Okay, but we're going to count along a horizontal or vertical line. So I'm going to count 1, 2, 3 to get from x to my line of reflection. Now, if I went right, I'm now going to go down. Okay, I'm going to go across the line in that direction. So if I go 1, 2, 3, I'm going to go down 1, 2, 3 to get to my x prime. Okay, same thing with y. Okay, I'm going to count 1, 2, 3, 4, 5, 6, 7. Then I'm going to go down 1, 2, 3, 4, 5, 6, 7. So from y to my line of reflection, I'm counting 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 1, 2, 3, 4, 5, 6, 7. Okay. Same thing with z. Count over 1, 2, then go down 1, 2. So it would work the same if we started, by going down and then right. Okay, so we just have to make sure that we're going in. If we go over to get to the line of reflection, then we go down. Okay, if we go up to get to the line of reflection, then we go over. So this would be my reflection across the line y equals x. So then we fill in our coordinates. Let's see, my new x is at, where are we? Negative 2, negative 5. Bless you. My new y is at 4, negative 3. Yes. And then my new z is at 1, negative 1. So Katie just pointed out that all of the coordinates are just flipped in the original. If I'm reflecting across the line y equals x, negative 5, negative 2 went to negative 2, negative 5. Negative 3, 4 went to 4, negative 3. And negative 1, 1 went to 1, negative 1. Okay, that will always be true if I'm reflecting across the line y equals x. It's literally saying y equals x, right? We're just flipping the y and the x coordinate. Okay? So visually, we're counting over and counting that same distance down. But in terms of the coordinates, all we're doing is flipping the x and the y coordinate. Okay? Feel okay with that idea? Okay, so go ahead and try number 10. Okay, number 10 is the same idea. We're reflecting across the line y equals x. Scotch tape or duct tape? Duct tape. One of the most popular air questions is to have you reflect across the line y equals x. Right? Something like that shows up on the air test almost every year. Nice. Did we get something like this? So the original figure was down here this time. So we ended up having to count up or left to get to the line of reflection. Then we would just go, so we went up, go left, went left, we would go up to get to my new coordinate points. Okay? And I mean, you can double check yourself two ways, right? You can literally fold your paper and make sure they match up, or you can make sure that the coordinates are just flipped. Okay. If you fold across this line, these will match up perfectly. Same thing with number 9. If you fold across the line y equals x, those two figures should match up perfectly. We okay with these? So then the last two on here ask us to do the line y equals negative x. What does the line y equals negative x look like? Same thing, just negative. Yeah, so this is a line with a y-intercept of 0 and a slope of negative 1. Right? So it's just going to be this line right here. So let's do it graphically first and see what happens to the coordinates. So if I plot these points, -1, 3 is A, 0, 6 B, 3, 5 is C, and then D is at 2, 2. So this actually makes a square. Right? So if I want to reflect A equals X, I'm going to count how far over, and go that same distance down. So A prime will be there, B, I'll go 1, 2, 3, down, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, then over 1, 2, 3, 4. And C. 1, 2, 3, 4, 5, 6, 7, 8. So over 1, 2, 3, 4, 5, 6, 7, 8. Right. So let's take a look at the coordinates then. So A, or my new A prime is now at 1, 2, 3, -3, 1. My new B value is at -6, 0. My new C value is at -5, -3. And my new D value is at -2, -2. So what happened? Yeah, so if I'm reflecting across the line y equals -x, I'm switching the coordinates and taking the opposite value of each one. Okay? So, I mean, yeah, that's essentially making it negative, but I like saying opposite better because if it's negative, make it positive. Okay? But, I mean, that would be a negative one. We're taking the negative of a negative number. So, I guess should have jotted this down for y equals x. We can put that back up there in a second. But if I'm reflecting across the line y equals negative x, I take my coordinate point. Okay, this is like the generic rule. I switch my coordinates and take the opposite of both of them. Okay, that's how we would write the generic rule. Okay, take a coordinate, switch them, and take the opposite of both of them. So if I wanted to write this same rule back up here for y equals x, I would say I take my original coordinate, and all I do is switch the x and the y. Right? So xy would go to yx. Questions on that? All right, go ahead and try number 12 then. You get something like this. Any questions on these ideas here? Pretty much it for today then. Got